Welcome to this lecture. It is a situation in which all the instructions are stuck due to data access reason or any other operation. A deadlock can be indicated by a cycle in the wait for graph. This is directed graph in which vertices denote transactions and the edges denote weights for data items. So Z, Y, X, these are the data items, and T1 is waiting for T2, T2 is waiting for T3, T3 is waiting for T1, and X, Y, Z, these are the data items, and these are the transaction T1, T2, T3. For example, in the following wait for graph, transaction T1 is waiting for data item Z, which is locked by T2. T2 is waiting for X, which is locked by T3, and T3 is waiting for X, which is locked by T1. So all the transactions are locked by each other. So what will be happen? A waiting cycle is formed and none of the transaction can proceed because all are waiting for each other. So T1 is waiting to access the atom T2. T2 want to access X, which is T3 from T3, and the cycle is continuous. So deadlock handling. There are three classical approaches for deadlock handling. So the first one, deadlock prevention. Second one, deadlock avoidance. Deadlock detection and removal is third one. These approaches are very useful in distributed databases and centralized database. We will explore all the approaches one by one. Here is first one is deadlock prevention. The deadlock prevention does not allow any transaction to perform a lock that will cause deadlock. So before this state, before transactions are going to deadlock, the prevention technique is to perform not allow any transaction to perform a lock that will cause deadlock. Make a situation in which there is no chance of deadlock. The convention is that when more than one transactions request for locking the same data item, only one of them is granted the lock. One of the most popular deadlock prevention methods is pre-equation. Of all the locks, in this method, a transaction acquires all the locks before starting to execute and retains the locks for the entire duration of transaction. And the next one is here, deadlock avoidance. So which is maintained by two steps. The deadlock avoidance approach handles deadlocks before they occur. T1, suppose T1 want to access data item which is already locked by T2. So wait die won't wait. So these are the two conditions. It analyzes the transactions and the logs to determine whether a lock is occurring or not, or we can say that whether a deadlock is occurring or not. Transactions start executing and request data items that they need to lock. The lock manager checks whether the lock is available. If it is available, the lock manager allocates the data item and the transaction acquires the lock. However, If the atom is locked by some other transaction in incompatible mode, the lock manager runs an algorithm to test whether keeping the transaction in waiting state will cause a deadlock or not. Like here we have a situation here that is T1 want to access data item which is already locked by T2. So first is wait die. So in wait die, if T1 is older than T2, T1 is allowed to wait. Otherwise, if T1 is younger than T2, T1 is aborted and later restarted. In second case, if T1 is older than T2, T2 is aborted and later restarted. Otherwise, if T1 is younger than T2, T1 is allowed to wait. So next is deadlock detection and removal. The deadlock detection and removal approach runs a deadlock detection algorithm periodically and removes deadlock in case there is one. To detect deadlock, the lock manager periodically checks. If the system has deadlock, the lock manager chooses a victim transaction that are the cause of deadlock from each cycle. The victim is aborted and rolled back and then restarted later. It does not check for deadlock when a transaction places a request for a lock. When a transaction requests a lock, the lock manager checks whether it is available. If it is available, the transaction is allowed to lock the data item. Otherwise, the transaction is allowed to wait. And next is deadlock handling in distributed database. Two concerns related to distributed database: deadlock handling, transaction location, transaction control. We are going to learn about two concerns that are related to deadlock in distributed database. Transaction processing in a distributed database system is also distributed. The same transaction may be processing at more than one site. The two main deadlock handling concurrence in a distributed database system: one side that are not present in centralized system are transaction location and transaction control. Because in distributed database, our databases are at different places that are logically related to one another. So first one is transaction location. A transaction may be cause of lock on the site in distributed database system. This issue is called transaction location issue. When two conflicting transactions are located in a site, it may happen that one of them is in inactive state. This condition does not arise in a centralized system. This concern is called transaction location issue. And the second one is transaction control. Control the site for transaction processing. Transaction control is concerned with designating and controlling the sites required for processing a transaction in a distributed database system. There are many options regarding the choice of where to process the transaction. So one server may be selected as the center of control. The center of control may travel from one server to another. The responsibility of controlling may be shared by a number of servers. So these are the steps for control the site for transaction processing. And here in distributed deadlock prevention approach, a transaction should acquire all the locks before starting to execute. This prevents deadlocks. A transaction should acquire all the logs before starting to execute. This prevents deadlocks. Next one is distributed deadlock avoidance. Distributed deadlock avoidance handles deadlock prior to occurrence. In distributed systems, transaction location and transaction control issues needs to be addressed. Due to the distributed nature of the transaction, the following conflicts may occur. Conflict between two transactions in the same site. Conflict between two transactions in different sites. So remove all the conflicts and distributed deadlock avoidance will be implemented by removing the conflicts. Distributed deadlock detection. The system does not perform any checks when a transaction places a lock request, same as centralized database. For implementation, existence of a cycle in the global wait for graph indicates deadlocks. However, it is difficult to spot deadlocks since transaction waits for resources across the network. So at the time of before occurrence or avoidance, so we can allow a site to access the site 2 or lock the atom of the site 2, and if there is a deadlock occur, then first detect and then remove the deadlock. So victim transaction should be deleted in distributed deadlock detection. So 3 distributed deadlock detection: centralized deadlock detection, hierarchical deadlock detection, and the third one is distributed deadlock detection. So these are the 3 detectors. So the first one is one site is designated as the central deadlock detector. So in centralized deadlock detector, we are used in centralized system. Hierarchical deadlock structure: a number of deadlock detectors are arranged in a hierarchy, like at step 1, then step 2, then step 3. So there are number of deadlock detectors that can detect the deadlock in hierarchical deadlock detector. But in centralized there is only one, that is in centralized database systems. Distributed deadlock detector: all the sites participating in detecting deadlocks and removing them. So in distributed database, all the sites, site 1, site 2, 3, 4, 5, so all the sites try to participate in detecting deadlocks. First detects the deadlock or find the deadlock and then remove them by removing the victim transaction that is going to cause of deadlock. Finally, here is our last slide, which is thank you so much for watching this video.